So I would like to introduce Florian. Florian is a master's student at the University for Applied Sciences Bonn-Rhein-Sieg in Germany. As part of his studies, he is working with the BSI in Germany, and during his time at the BSI, he developed Katti, which will be the topic of his talk. So over to you, Florian.
Yeah, thanks for the nice introduction and for having me here. Yeah, so my talk is about Katti, and the title has already revealed it. Katti is a detection system for Ad-Malware. And as of part of my studies, I have started to develop Katti in cooperation with the BSI a year ago. And yeah, BSI is a short term for Bundesamt für Sicherheit in Informationstechnik, and in English, Federal Office for Information Security. And Katti is also used in the context of my master thesis. And at the end of my talk, I will say a few sentences about the thesis. Yeah, but first, I would like to clarify the term Ad-Malware. Short and to the point, Ad-Malware is malware spread over the online advertising system, especially with the help of the programmatic advertising. And Ad-Malware has the great advantages for criminals that they don't have to compromise network infrastructure such a web server, and that they can spread the Ad-Malware over large numbers of websites. So it doesn't matter whether it's a big news site like CNN or a small private blog. And the only requirement is that the website display ads. Yeah, and there exist different variations of Ad-Malware. For example, drive-by download or the classic phishing. And an example of a famous Ad-Malware campaign is eyeo, which was discovered by the IT security company Confient last year. So, but why have started to develop Katti? What is the motivation, or what was the motivation? And yeah, the following quotation describes it quite well. It's commonly known that Ad-Malware exists and that the programmatic advertising itself is a part of the problem. Recent research, publications, and past attacks like eyeo confirm this. So the question is not whether Ad-Malware exists, the question is how big the problem is. And this is where the problems start. Also, the existence of Ad-Malware is undeniable. It is impossible to provide an up-to-date situation picture of the distribution of Ad-Malware. But without an up-to-date situation picture, it's impossible for the BSI to take countermeasures. For example, to stop or to slow down an Ad-Malware campaign early enough to prevent damage. Additional, that the BSI can't take effective countermeasures, the end users haven't real opportunities to protect themselves, besides the use of an ad blocker with all the downsides. Yeah, and this is where Katti comes into play. In future, Katti should enable the BSI to provide an up-to-date situation picture, and this enables the BSI to act at an early stage and take effective countermeasures. So, yeah, now, but how is Katti working? Yeah, this will be a Katti in a nutshell slide. The graphic gives you a crudely simplified overview about the system. And as you can see, Katti basically consists of two parts. The first, we have the calling part, and the second, you have the analyze part. In the middle, you have a database, and a MongoDB instance is used as a database. The calling part consists of a set of crawlers. And the crawlers visit the websites, interact with the display, with the displayed ads, and store the resulting data, such the whole HTTP traffic. And interacting with the displayed ads means that the systems simulates a user click on the ads. Yeah, and the base for this calling process is an URL list, and the list contains up to hundreds of thousand URLs. For example, the Tranquil list is a quite good source for such a list. Yeah, and the main component of each crawler is the crawler engine. And to keep it simple, the calling engine is a big wrapper for Selenium Wire, and it's implemented in Python like the whole system. And furthermore, real browsers, for example, Firefox or Google Chrome, are used for the crawling process. One of the advantages of using a real web browser is that it's easier to fool browser fingerprinting techniques. And Selenium Wire is an extension for the Selenium framework. And Selenium Wire expands Selenium with a proxy architecture. And because of this architecture, it's possible to capture and manipulate the whole HTTP traffic in an easy way. For example, the user agent field. Yeah, after the crawler have collected the data, Katti has to make the decision if it's malware, Ad-Malware or not. And yeah, several detection approaches were published in the last few years. For an example, one approach is to use the Google Self-Browsing API. And the approach is quite simple. You check all requests which belong to a special advertising impression. In case of a positive match, it's Ad-Malware. Yeah, and one of Katti's core features is that the system is not fixed on a set of approaches. So instead, the framework is embedded, which allows you to add further analysts to Katti in an easy way. Yeah, and in the context of Katti, an analyst is the implementation of a concrete approach. And because of this framework, the general process with an analyst is always the same. Yeah? So the first step is the analyst fetch the next data set. And in the second step, all the magic is happened. Yeah? So the analyst decides based on the implemented approach, it is Ad-Malware or not. And the third step is that the analyst store the results into the database. Yeah. This was a brief overview about Katti. And next, I would like to talk about one of my challenges during development. And I called this problem the freezing problem. And the problem cropped up during the implementation of the crawling engine. And in my opinion, it's a common problem. And therefore, everyone who builds a crawling engine on the base of Selenium needs to keep it in mind. After I had developed my crawling engine, I started to test it. But after a few hours or sometimes days, and no matter which URLs were loaded, the execution of my test crawler stopped. And the execution was frozen for no apparent reason, and it was unable to react, for example, with a simple with an accept statement or something like this, because the program lost the control over the complete execution flow. Yeah, and I don't know the exact reason for this behavior, but I think it's something like a race condition within the Selenium framework. Yeah, and it was for me very time-consuming to find the solution, because at first I assumed that the problem was caused by an error in my code, and additional, I didn't find anything helpful in the internet. And the solution to avoid this problem is at the end quite simple. It's a timer. So at the moment when the crawler starts to visit the web page, the timer starts. And in the case that the timer runs out, a self-killing mechanism is automatically executed. And after the crawler has died, the crawler is rebuilt by a control process based on a backup. And among other things, the backup contains the last valid state of the web browser. Yeah, and on this slide, I've summarized the core features of Katti. So Katti is browser and operating system independent. The crawler engine is based on Selenium Wire. You can find the framework on GitHub, and the whole HTTP traffic is manipulated or captured. And the flexible, and Katti is flexible in terms of the detection approaches that can be used. At least I will talk a little bit about my master thesis. As I've told you, there exist several detection approaches. And as far as I know, there's no publication that compares these approaches. But this is necessary to decide which approaches to use in the final system. In my thesis, I will do this. So I will compare the different approaches. Additional, I will provide an up-to-date situation picture about the distribution of Ad-Malware. Yeah, and as preparation for my thesis, I conducted a pre-test with Katti, and the Google self-browsing API approach was used for the detection. And to conclude the results, I found Ad-Malware, and this also proves what I said in my motivation part. Yeah. And thanks. Thanks for your attention. Yeah.
Nice. Oh, thank you so much. And that was awesome and punchy in the lightning talk time. So we actually do have 2 questions for you if we can sneak those in. We'll see how time goes. The one is, given that most ads are targeted, how do you ensure that the ads displayed to your crawlers are representative of the ads displayed to users?
Yeah, so first of all, my crawlers use a real web browser, yeah? And every time when the web browser starts the crawling process, it's like a never used Firefox browser, for example, yeah? And the second is, there's also a part with this part you can fool the targeting techniques, and not only the HTTP headers. We are also enabled to produce real user profiles, yeah, and this part is it's something similar like to the track this project of Firefox, yeah. So we are sure that we can fool the targeting techniques, and so we have at the end representative ads for users, yeah.
Awesome, thank you. The second question, which we can probably fit in still, is from Tim. For interacting with ads, you actually first need to identify ads on a given page. How is that being done?
We concentrate on ads which are displayed in iframes. So it's the first. We are only looking for iframes, and the second is we have a real-time check for ads. So we used in the system the filter engine of Adblock Plus, and when in the moment when a request, which is from an iframe, is matched like this is ad, then the system say, okay, the whole iframe is ad. So this is how the identification works.
Brilliant. Thank you so much. And that's almost bang on time. And there's one more question which we'll take on over to Slack. So just thank you again so much for your time. It was hugely valuable.
Okay, thanks.